Now look, unless you have been in hibernation for the last 20 years, you know that in the last 2 decades, we had the math wars. And one of the lightning rods in the math wars was the standard algorithms. You know that, right? Whether or not to teach it. It took me a while to come to grips with this phenomenon. And even this is the second day we're together, right? You know exactly what I'm going to say. If in the universities who have taken greater pain to educate our teachers, our educators in mathematics, math wars would never have happened. That's a completely silly question as to whether the standard algorithm should be taught. To even raise this question is a statement that the people in that discussion, the people who object to having the standard algorithms taught, basically do not understand something as basic as the standard algorithms. What are they? Well, depends how you look at it. You look at the standard algorithms as they are taught in textbooks. What do they become? A series of procedures that actually no, nothing. When that happens, yes, nothing ever should be taught. But if that's all you worry about, then you should not teach any. You should take away all of school mathematics and not teach it, because how often you get any kind of reasoning in school mathematics? You know, even though some of you are not in high school, most of you are not teaching high school, right? You know this thing about high school geometry. In high school geometry, the purists, or whatever you call those people, would say, that's where you learn reasoning in geometry. There you have to start with axioms, you have to prove theorems. That's when you really learn something. You heard of this statement? No? You never heard of it? Really? You never heard of it? That's interesting, actually. But it's business all over the place. So those of you high school teachers, of course, know this. But it's in the papers. It was definitely a bone of contention. Well, okay, whether you know it or not, such thing was said. And if something like that is said, you know something is terribly wrong. Because it says what? You don't learn to reason at all until you come to a geometry class. That's what it says. But that says what? The mathematics we taught. It's not mathematics. There's no reasoning at all. Like that's what we're trying to address. This is the issue we're trying to address. All this care about explaining this, explaining that, is to make sure that you can go back and feel completely comfortable explaining to your students everything they want to know. If that happens, okay, so if that happens, then it happens to standard algorithms. If standard algorithms are taught that way, why should there be any reason for people to say we shouldn't teach it? Can you think of even one reason? It's not. But the fact is that nobody ever looks at standard algorithms seriously, looks at standard algorithms seriously, and asks and explain to our teachers, to our educators, and say, this is what it is, and if that had been done, the question of whether or not to teach it would never have been raised. Mathematics is mathematics, why not teach it? So we're going to do standard algorithms in the next 3 days. Oh, no, 2.5 days. So what are they? All right, so that's a question I want to ask you, for example. What do you think of the standard? Okay, do you think you want to teach the standard algorithms? And if so, why? Suppose I'm asking you, right? Enemy territory. In enemy territory, right? Your kid raises his hand or her hand and says, "Why should I learn this?" What do you say? Well, you're put on the spot, right? So what do you say? Aaron, you want to talk? The many reasons. You can just pick one.
The standard algorithms. Sorry, could you repeat once more, please?
Could
you repeat once more?
Oh yeah. Should I be learning the standard algorithms, Mr. Jorgensen?
Because I said so.
Exactly. Right. That's exactly.
Got it.
That's right. Exactly. All right. Maybe.
I'll say because you can't carry that many base 10 blocks in your pocket.
That's a good answer. That's a good answer.
I mean, you could give a kind of a big, crazy problem and say, how do you plan to do this?
Mm-hmm. Give me an example of such a crazy big.
I mean, 56,922. And just how are you just going to do it mentally? Or are you going to sit there and?
Oh, I didn't do that. I have calculated.
That's true.
You haven't seen one? In fact, that was the basis of that whole math. That was what instigated the whole fight.
How do you know?
With the advent of calculators, all I have to be told is when you see this, you do that, and that's the end of that discussion. Oh no, that's exactly. I didn't present it well. I thought you knew because the calculators began to be what? When I thought that's very funny. In 1978, I bought my first calculator, and I could deduct it from my income tax return. That was 1972, 73. It was expensive. I think it was $40 back then. $40 back then is now what? I deducted it anyway, so don't feel bad for me. From income tax. So that was a rarity. But by 1990, that's exactly why it came up. The math wars started in 1990. It was what? $10 or maybe less, right? Everybody has a calculator. So why should I learn standard algorithms? See no reason. Sorry?
What if the battery goes in your calculator?
Solar.
I always carry two, Larry.
Then I just get out my phone.
That's not a good argument. Yeah?
But how will you know if you've made a mistake? By pushing buttons, pushing the wrong button.
How do you not make a mistake by doing your pencil and paper calculation?
You never know that.
That's not a very good argument. You as a teacher, you have to think about this. Now, what I'm trying to get you to do is that you don't just teach. When you teach, you ask, I'm going to make them learn something. And you be sure that this is hard work. Learning mathematics is not a walk in the park. On the other hand, it doesn't take genius. That's the two sides to it. One, it requires work. If anyone tells you can learn mathematics without work, forget it. That guy is just learning. Right? On the other hand, you take time. Does it take talent to learn this kind of mathematics? The answer is emphatically no. All it takes is you're careful, you listen, you do things studiously. That's all it takes. You should be aware of both things. And therefore, if you want to make them do work, you had better be sure that it's worth their while. Therefore, you must know why you put them through their paces. Why? What excuse you have for inflicting misery, right? That's the issue. And you have to think about this question. I do, when I stand here, I think about all the contingencies. You know, you're going to say, why you want to do this? Tell me, I'll answer you. So that's why, so the issue of motivation, of incentive, if you can begin to think like that, you'll be a much better teacher. In other words, whatever you teach, you tell them, you should learn it because this wonderful thing waiting for you. Right? Standard algorithms, you just teach that, not really to learn computational power. You don't do that. As I said, every calculator can outdo you 100 to 1. Right? But standard algorithms must be learned because, well, there are many reasons. As I said, Kelly gave one, and who was it gave another one? WuMPDI gave another, right? There are many. But the principal reason is that, well, are you trying to learn mathematics or not? Yes. Now, that I cannot answer that. If a student asks me, why should I learn mathematics? I can only say, well, no, 21st century, you don't learn mathematics, you're going to starve. But as far as I can go, but I don't think I do much better than that. So let's leave that aside, right? So in school, you're supposed to learn what you're supposed to learn. I mean, you can say, in this society, you want any kind of a reasonable living, you have to learn how to think. And there's no better way to learn how to think than to do mathematics, because that's, as far as the school curriculum is concerned, mathematics is pure thought, pure thinking. And no other subject quite like it. That's training ground for thinking. So, if I teach you standard algorithms, I better teach you how to think. So what kind of thinking is involved? Well, there are many things. You're going to do algebra or not? You want to do algebra? Well, you have to learn to do symbolic computations. You don't just do symbolic computations overnight. You need some training. Instead, learning to understand the standard algorithms, that is about as good a training as you can get in any kind of mathematics, by the way. The standard algorithms are high-level mathematics, no matter who says what. Don't let anyone convince you otherwise. There's no question about it. In other words, mathematicians like to say, like good mathematics and bad mathematics. And you have to trust me that any working mathematician will tell you the reasoning behind the standard algorithms is very high-level mathematics, worthy of greatest respect. So you want to learn how to think. But we can be more precise than that. After all that, after you learn the standard algorithms, do you come out with a single impression? Is there something you can say, that's what I've learned? The answer is yes. There's one single strand that runs through all 4 algorithms. Namely, if you know how to do single-digit computations, you can compute with any numbers, no matter how big. Single-digit computations control everything in whole number computations. That is the whole issue. When you learn the standard algorithms, you're learning about this wonderful fact. If you know this, you will have a much better handle in talking to your 3rd graders or 4th graders who protested you that they don't want to learn the multiplication table. Why do you want to learn the multiplication table? Well, you understand what the standard algorithms are about. You know that the learning about single-digit computations allows you to compute everything, right? In particular, what is a What is the multiplication table? What is it? In one sentence, what is it? No, no, no. What is the multiplication table all about? No. No, you learn how to compute all single-digit multiplications. That is what it is. Think about it now. Right or wrong? Do I make you memorize 11 by 12? 11 times 12? 12 times 13? No. It's about single-digit multiplications. 1 through 9. Right? That is the basis of all multiplications. Unless you say you don't want to learn it. Learn mathematics. That's one issue. But if you say you want to learn mathematics, you have to commit that to memory. It's just the same as saying, you want to write or not? You want to write? Memorize the alphabet. Did anyone object? First grade? No, I hope not. Why should they object in third grade? Alphabet is 26 bits of memory, right? Multiplication table is about 45, not that far away. Oh, by the way, you know why it's about 45, right? Why is it only about 45? Yes. I say that because what's the reason?
Community.
Yeah, community. That's why you use it. You can do 25, you can do 25, 26, you can do 45. Come on. Right? This is why you have to memorize it, because otherwise you can't go forward. So that's right. So what we want to do in the next 2.5 days is to convince you completely that if I can add single digits. Oh yeah! Okay, Wendy and somebody else who's primary school. Oh yeah, Deborah. Somebody else who is. Kathy? Oh! You make them learn single-digit addition, remember? Right?
We try.
Obviously you succeeded.
To all you middle school teachers, we're trying.
But that's the idea, right? This is why to learn 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 8, 1 plus 7 plus 6, 7 plus 5, 7, so on. Exactly the same idea. The single-digit additions that you have to learn, that they have to learn in first grade, is the exact analog of the multiplication table. They have to learn in third or fourth. They are single-digit operations. I'll tell you a joke. It's not high-level jokes are probably not very funny. I think it's still on the web, but maybe they have taken it down. Go to Texas. You can get a hold of on the web a version of the Texas math standards. I'm sure you can still go. It's written in the standards that kids in third grade have to learn the multiplication of all numbers between 1 and 12, from 1 to 12. In other words, Texas kids have to know 9 times 12 is by memory. You know, I can't do it. I guess 108. 11 times 7. Oh, that's easy. But 7 times 12. 5 times 12. Oh, anyway, you get the idea. Now, the guys who wrote that down is totally mathematically illiterate. You know why now? Do you know why? Now, you know, after I've given all this explanation, you know why that is just very, very bad? You know? What? What?
There's no need to learn.
Yes, what's the whole point? I'll try to tell you. What is the whole point of memorizing multiplication table? You want to furnish a basis for multiplying numbers. What do you need? Single-digit numbers. So what are 10, 11, 12 doing there? This is plain stupid. Well, it's in this step. But the amount of mathematical literacy in this world is just immense. Nowadays, I think many people laugh at it, so they're taking it down. So you may not be able to get it, but if you get on one of the old websites, you can still get it. See, so I mean, that's called, you don't want to teach like that. You don't want to teach like that. Making students do work that are completely unnecessary. But in order to not do that, you have to know mathematics, you see? That's why there's no escape. Content dictates pedagogy. Yeah?
Do you have any idea why it has typically been accepted to do everything up to 12 by 12?
It probably has something to do with the what do you call the British system, the one that they
Customary measurement.
Yeah, I mean the inches of the 1 to 12. I don't know. I'm just guessing because that's the only rational explanation. And some guy, you see, that's one reason. I think there's another reason. Some people got the idea that if you want to say that Texans are smarter than the rest of the country, you have to show that they know more. And to them, knowing simply means memorizing more. Therefore, make their kids memorize up to 12 rather than up to 9 shows it. Better.
Everything is better in Texas.
Yeah.
Better and bigger.